Welcome back to our YouTube channel. If you are new here, make sure to subscribe and hit the bell icon to stay updated with our latest content. Hi, I'm Saaz, an IT specialist and a proud member of the web development team. Today I'm going to show you how someone finds your location easily in just 3 minutes. Let's get started. Hound. Hound is a simple and light tool for information gathering and capturing exact GPS coordinates. So, what is Hound? Hound is a tool that can remotely capture the exact GPS coordinates of a target device using a PHP server, and can also grab basic information about the system and ISP. This tool can be very helpful in information gathering. You can get the following information of the target device: longitude, latitude, device model, operating system, number of CPU cores, screen resolution, user agent, public IP address, browser name, ISP information. This tool has been tested on Kali Linux, Windows, WSL, Termux, MacOS, Ubuntu, and ParrotSec OS. IP Address Geolocation. A common technique for tracking someone's location online involves IP geolocation. Here's how this works. Step 1. Identifying the target's IP address. A hacker can obtain an IP address through methods such as phishing, social engineering, or malicious software like Trojans. For example, when you visit a website, your device sends a request to the server, and this request includes your IP address. Step 2. Using an IP lookup tool. Once the hacker has the target's IP address, they can use an IP geolocation service, many of which are publicly available, to estimate the physical location of the IP. Now, accuracy. This process is not always highly accurate. It can generally provide a city or region but not a specific address. An IP geolocation lookup tool might give a general location, but it wouldn't be precise enough to pinpoint someone's exact home address unless the hacker has access to more specific data, like Wi-Fi or GPS information. Social engineering and phishing. Another method that could be associated with a tool named Hound is social engineering. Here's how this can work. Step 1. Luring the victim into revealing information. Hackers might create fake websites or emails to trick the target into revealing information such as IP address, location, or even logging into their devices. For example, a phishing email may ask the target to click a link, which could execute code that reveals their IP or location. Step 2. Gaining access to location data. Once the hacker has access to the victim's device, they can use malicious software to track GPS or access data from mobile apps or photos that contain location information. For example, photos taken with smartphones often contain EXIF metadata, which includes GPS coordinates. Wi-Fi or Bluetooth location tracking. Hackers can also use Wi-Fi and Bluetooth tracking to estimate someone's location, especially if the target's device has location-based services enabled. Step 1. Scanning for signals. The hacker might scan for nearby Wi-Fi networks or Bluetooth devices. Step 2. Mapping the location. By comparing the strength of signals from Wi-Fi routers or Bluetooth devices, a hacker can triangulate a general location. Example: in some cases, hackers might not directly hack into the device, but can use publicly available databases of known Wi-Fi network locations to estimate where a person is based on the Wi-Fi they're connected to. Malware or spyware. GPS tracking. If the hacker can install malware on the victim's device through phishing or malicious downloads, they can track real-time GPS locations. Step 1. Infecting the target device. The hacker might send a malicious link or file that installs spyware or malware that tracks the device's location. Step 2. Real-time location tracking. If the malware has access to the GPS feature on the device, like a smartphone, the hacker can see the device's location on a map in real time. Example: you could demonstrate this concept through a hypothetical scenario where a hacker uses malware to access someone's phone and track their movements.
Hound operates by setting a digital trap. It uses a PHP server to collect a treasure trove of data about its unsuspecting victims. One of the primary targets of Hound is a device's GPS coordinates. GPS coordinates, consisting of latitude and longitude, provide a precise location of the device, effectively putting a dot on a map where the device, and presumably its owner, is located. But Hound's data appetite doesn't stop there. In addition to GPS coordinates, the tool is also designed to collect a range of other device information, painting a comprehensive picture of the target and their digital footprint. This information includes details about the device itself, such as the device model and operating system. Furthermore, Hound can capture the device's IP address, which can be used to determine the user's internet service provider and their approximate geographical location. It also collects browser details, providing insights into the user's browsing habits and potentially exposing them to targeted attacks. The depth and breadth of data that Hound can gather make it a powerful tool in the wrong hands and a stark reminder of the importance of cybersecurity awareness and vigilance. One of the factors contributing to Hound's potential for misuse is its ease of installation and operation. The tool can be readily installed and operated on popular operating systems used by cybersecurity professionals and hackers alike. For instance, Kali Linux, a Debian-based Linux distribution widely used for penetration testing and ethical hacking, provides a suitable environment for running Hound. Similarly, Termux, a terminal emulator and Linux environment application available on Android, can also be used to install and operate Hound. The accessibility of Hound on these platforms makes it a tool within reach for a wide range of individuals, from cybersecurity enthusiasts to malicious actors. The installation process typically involves downloading the Hound script from a platform like GitHub, and then executing a series of commands to install the necessary dependencies and set up the PHP server. Once the installation is complete, operating Hound is relatively straightforward. The attacker needs to create a malicious link or web page that, when clicked by the victim, redirects them to the PHP server running Hound. This server then captures the victim's device information, including GPS coordinates, and stores it for the attacker to access. The simplicity of this process belies the potential consequences, highlighting the importance of cybersecurity awareness and the need for robust security measures to protect against such threats. The existence of tools like Hound raises profound ethical questions about the balance between security research and the potential for misuse. On the one hand, Hound and similar tools are often developed with the intention of helping security researchers identify vulnerabilities and improve the security of systems and applications. Ethical hackers, also known as white hat hackers, use tools like Hound to simulate real-world attacks and test the effectiveness of security measures. By identifying vulnerabilities before malicious actors can exploit them, ethical hackers play a crucial role in making the digital world a safer place. However, the dual-use nature of tools like Hound means that they can just as easily be used for malicious purposes. The same features that make Hound valuable for security research, its ability to capture location data, device information, and other sensitive data, also make it a powerful weapon in the hands of stalkers, hackers, and other malicious actors. The potential consequences of such misuse are significant, ranging from invasion of privacy to physical harm. Therefore, it is crucial to use tools like Hound responsibly and ethically, adhering to legal and ethical guidelines. The cybersecurity community has a responsibility to promote responsible disclosure policies, ensuring that vulnerabilities are reported to the relevant authorities and software developers so that they can be patched before they are exploited. Section 5. Legitimate uses of GPS beyond the realm of hacking. GPS technology has revolutionized our lives with its wide range of legitimate applications. Navigation is the most common use, guiding drivers, pilots, and sailors. GPS is crucial in emergency services, transmitting locations to responders. It also tracks valuable assets and aids in precision farming. Recognize the positive impact of GPS on our lives. Section 6. Demystifying GPS technology, satellites, signals, and accuracy. To understand how GPS technology can be exploited, it is essential to grasp the fundamental principles of how GPS works. GPS is a satellite-based system providing location and time information anywhere on Earth. It consists of satellites, control stations, and GPS receivers. Receivers calculate distance from satellites by measuring signal travel time. Using trilateration, the receiver determines its precise location. Accuracy can be affected by atmospheric conditions and signal obstructions. Section 7. Real-world GPS trackers, features, and applications. GPS technology has manifested in various physical devices for tracking and location monitoring. These devices, known as GPS trackers, cater to a wide range of applications. One common type is for tracking vehicles. These small, discrete devices can be hidden inside a car. They track the vehicle's location in real time. Some offer geofencing and speed alerts. Another application is pet tracking. Pet trackers provide real-time updates on pets' whereabouts. GPS trackers are also used for valuable assets like laptops and luggage. These small trackers can be concealed within the asset for security. Section 8. Beyond GPS. The expanding landscape of location tracking. While GPS technology has become synonymous with location tracking, it is important to recognize that GPS is not the only method for determining a device's or individual's location. As technology continues to evolve, new methods of location tracking are emerging, often relying on a combination of technologies and data sources. One such method is Wi-Fi positioning. Wi-Fi positioning leverages the widespread availability of Wi-Fi networks to estimate a device's location. When a device with Wi-Fi enabled is within range of a Wi-Fi network, it can detect the network's presence and signal strength. By analyzing the signal strengths of multiple Wi-Fi networks, a device can triangulate its approximate location. Another emerging location tracking method is Bluetooth beaconing. Bluetooth beacons are small, low-power devices that emit Bluetooth signals. These signals can be detected by nearby devices, such as smartphones, allowing businesses and organizations to track the movements of individuals within a specific area. Bluetooth beacons are often used in retail environments to track customer foot traffic, provide personalized offers, and enhance the overall shopping experience. Furthermore, cellular network-based location tracking uses cell tower triangulation to estimate a device's location. By analyzing the signal strength and timing information from multiple cell towers, a device can determine its approximate location within the cellular network. Section 9. The many faces of Hound separating fact from fiction. In the world of cybersecurity, terminology can be fluid, and the same name can be used for different tools with distinct functionalities. This ambiguity can sometimes lead to confusion, especially when dealing with tools that have the potential for misuse. The term Hound is a prime example of this phenomenon. While this essay has focused on Hound as a tool for capturing GPS coordinates and other device information, it is important to note that other tools exist with the same name, but completely different purposes. For instance, a quick search on GitHub reveals a tool called Hound, designed for fast code searching. This particular Hound is not related to location tracking or hacking in any way. It is a legitimate tool used by developers to search through large code bases quickly and efficiently. The existence of multiple tools with the same name underscores the importance of context and specificity when discussing cybersecurity threats. It is not enough to simply refer to a tool by its name. It is crucial to provide additional details, such as its functionality, developer, and intended purpose, to avoid confusion and ensure clear communication.